One variable calculus, module 3. In module 3, we have 5 topics. First topic is Rolle's theorem. Second topic is mean value theorem. Third one is Taylor's and Maclaurin's theorems with reminders. Fourth one, L'Hospital rule, indeterminate forms of L'Hospital rules. Last one is maximum. Among these five topics, among these five topics, important topics are these three. These three important topics. Today class, we are going to see about the Rolle's theorem, about the first topic, Rolle's theorem. The statement of the Rolle's theorem is if a function f of x is continuous on closed interval a comma b, and second condition f of x is differentiable on open interval a comma b, and along these two conditions, one more condition is the function value at the endpoints of the interval f of a, function value at a, one endpoint, is same as function value at other endpoint. If the function satisfies these three conditions, then there exists a point C, there exists a point C in the open interval a comma b such that f dash c equal to 0. Here you see these three conditions hypothesis. Above three conditions are hypothesis. F of x is continuous on the closed interval. Second condition is f of x is differentiable on the open interval a comma. Third condition is f of a equal to f of b. If these three conditions are satisfied, then there exists a point in between a comma b. Suppose interval. Interval always continuous model. There is no any gap between these two. Real numbers always denoted by a line. Interval is a part of a line. Interval is a part of a real line. So it always continuous model. There is no any gap between. There exists a point C in anywhere in between A and B. Not C is not equal to A as well as C not equal to B, but it is a in between. Such that at this point the function derivative value is zero. The function derivative value is zero. As per uh, data science student, you must remember this is the source. These three conditions are sources. Destination is this one. Source to destination. We start from the source. We reach to destination. This is the statement. You remember the statement of the Rolle's theorem. Whenever you prepare for the examination point of view, from this third unit, you must remember the statements of the theorem and problems. Based on the theorem statement, we need to solve the problems. Please, one more time, I am repeating here. Function f or f of x, usually called f or f of x. Both are same meaning. F of x is continuous on the closed interval a comma b. F of x is differentiable on open interval a comma b. Along these two conditions, the function value is same as at the endpoints f of a equal to f of b. If these three conditions satisfies the function, then there exists a point C between the open interval a comma b such that f dash c equal to 0. Please see the graph of the function look like this. Function means source to destination. X values, that means source values taken on x axis. Usually f of x means x is dependent variable. X values taken along x, taken horizontal line, x values. So in the x-axis we take central. This is the domain. So draw the function curve. It is a continuous curve, means without lifting the pen, we get a curve. These kind of curves are continuous curves. One more thing, this edge is called sharp edge. At this sharp edge, there is no derivatives. So the graph has no sharp edges. At these endpoints, the derivative does not exist. If the curve is smooth curve like this, no sharp edges, that time the function has a derivative at every point. At sharp edges, the function has no derivatives. No need to learn too much. Just you remember the graphical name. So at the function at the point A and at point B, function value is same. That means its corresponding destination value, y value. If you have any confusion, write it like oh, draw a line. So curve is something, any shape. So see, observe that at A, function value is f of A. At B, function value is f of B. Both are coincident. Now in the graph, you observe that at this point or at this point, right, or at this point, draw a tangent. Suppose this is C. This point is C. Corresponding point is C. At C, C1, C2, the tangent line parallel to the x-axis. That means at C, tangent means its derivative value, f dash value. At C equal to 0. Derivative value is 0 because the tangent parallel to x-axis, that time the variation of the y coordinates is 0. Just you simply remember tangent parallel to the x-axis at any particular point, then the function value should be, then the function derivative value should be 0 at that point. Here C, at C, take a C point in between A comma B. C, its corresponding graph image value here. At that point, you draw a line. Suppose if you take here point, if you draw a line, draw a tangent line. Tangent line means touch at a single point, not at all points, parallel to along to the curve. This is a curve. At a point C, its image is f of C. At the point C, you draw a tangent. Tangent means a line passing through corresponding point only, not all the points of the curve. These lines are called tangent to the corresponding curve at the corresponding point. So this line equation is f dash. At this f dash value for the particular point, value is 0. Tangent is 0 because there is no y coordinate change. Similarly here also, tangent are 0. This is the approach in the Rolle's theorem. The main important thing is to solve the problems only important. You remember one more time, I am repeating these 3 points. These 3 are hypotheses. F of x is continuous, f of x is differentiable, and f of a equal to f of b. These are the hypotheses. Conclusion is then there exists a point C in between a comma b such that f dash c equals to 0. Now we start the problem. There are two ways to ask a problem. The first type of problem is type 1 problem. Based on the Rolle's theorem, they may ask two types. Type 1. Verify the Rolle's theorem. Type 1 model is verify the Rolle's theorem. So, for example, first problem. Verify the Rolle's theorem. First one. Take a problem. Verify problem 1. verify Rolle's theorem for the given function. F of x equal to sin x by e power x in the interval. Verify means you need to verify hypothesis as well as conclusion. Hypothesis as well as conclusion. Here we will try to prove or verify, proof or answer or solution. Verify means first verify the hypothesis. Hypothesis. Verify the hypothesis. If you have any confusion, write down verify the hypothesis. There are three hypotheses. First one is continuous. First one is continuous. Sin x exponential. Sin x is trigonometric function. Exponential is also a continuous function. Please listen. Polynomials, trigonometric functions, exponential functions are continuous. Therefore, as per mathematics, continuous function by continuous function is also continuous. Sin x is continuous because it is trigonometric. E power x is exponential, so it is continuous. Continuous by continuous is continuous. Is continuous on closed interval. One small restriction actually, f of x is continuous on all the points except denominator never be equal to 0. Whenever substitute the point x values in the denominator function, the denominator it, it should be 0. That time you avoid those points from this interval. In the remaining points, the function is continuous. Here, if you substitute any point, e power x never be 0. Exponential function never be 0 for the finite values. So, sin x by e power x is continuous because sin x and e power x both are continuous. Second condition, it is trivially true. Sin x is differentiable. Trigonometric function sin x, cos x, all are differentiable. Polynomial functions. E power x exponential function always differentiable anytime, any number of times. Both are differentiable infinite number of times. So sin x by e power x is also differentiable. Differentiable on the open interval 0, pi. Here the given interval is 0, pi. A value is 0, B value is pi. Third one, substitute the f of 0 value because the end point of the interval is one end is 0, another end is pi. Find f of 0 value. F of 0 means sin 0 by e power 0. Sin 0 always 0. 0 by e power 0 value is 1. 0 by 1 equal to 0. Similarly, find f of other end point value at the function. Other end value, other end point is pi. Find the function value at the other end point. F of pi. This value becomes sin pi by e power pi. Sin pi value is 0. 0 by e power pi is non-zero value. 0 by non-zero value is 0. So you observe that these two values are coincident. That means f of 0 value endpoint at the endpoint the function value is same. Both are same. So hypothesis over. Conclusion. So if the hypothesis satisfies the given function as per Rolle's theorem by Rolle's theorem, because this is a hypothesis of the Rolle's theorem by Rolle's theorem by Rolle's theorem, there exists a point C in between 0, pi such that the derivative at the point C equal to 0. Now we want to find C value. Now we want to find C value. Here the process of derivation is f dash C. You find f dash x. Put x equal to C on the left hand side. Make into 0. We get a C value. So now f of x value is sin x by e power x. Therefore, as per derivative principle, f dash x value equal to, this is u by v form. I think most of them from mathematics background, data science students. D by dx of u by v equal to v square v into denominator square into denominator into derivative of numerator minus numerator value into derivative of denominator. Using this formula, using this formula, here the resultant value is e power x whole square denominator square into denominator into derivative of numerator. Sin x derivative becomes cos x minus numerator into derivative of denominator becomes e power x. E power x. Now simplify this value e power x cos x minus sin x by e power 2x. As per Rolle's theorem, f dash c equal to 0. Put x equal to c. Put x equal to c in f dash x. Then we get f dash c equal to e power c into cos c minus sin c by e power 2c. But we know this value. This value equal to 0 because as per Rolle's theorem, the point c exists between 0 to pi such that whose derivative equal to 0 by the Rolle's theorem. That means using this two equal a equal to b, b equal to c means a equal to b equal to c. Using this one, you simplify the expression, find c value. Here, e power c into cos c minus sin c equal to, take a cross multiplication from here to here. You get 0 into 2 power e power 2c. 0 into something equal to 0 in the right hand side. That implies e power c into cos c minus sin c equal to 0. That implies product of two functions are 0 if and only if any one of them 0. But e power c exponential never be 0. Therefore, we have any confusion, right? E power c equal to 0 or any one of them 0. 2 into 3 is never be 0 because both are non-zero. Likewise, any one of them should be 0, then the product must be 0. So here, either this one is 0 or this one 0, but it never be 0, exponential. Therefore, second one should be 0. Cos c minus sin c equal to 0 because e power c never be 0. For any c, put any c finite value, this value never be 0. That implies cos c minus sin c equal to 0 means cos c equal to sin c. Move the right hand side term to the left side, 0 plus sin c becomes 0. As per trigonometric values, both cos and sin have the same value at the point pi by 4. At the point pi by 4. Tan theta equal to 45 degrees. Pi by 4 means 45 degrees. Hence the Rolle's theorem. This is one kind of next model. Type 2 model. Type 2. Type 2. The type 2 model, they ask a question like this. Using Rolle's theorem, using Rolle's theorem, using Rolle's theorem, using Rolle's theorem for the function f of x, given function f of x, find the value of x between a and where f dash x equal to using Rolle's theorem for f of x, find the value of x between a and b, where f of x equal to 0. Here, no need to verify the hypothesis. Just prove the conclusion. That means find the C value. Find the C value. Here we take a one more problem regarding this concept. Very easy. It is a first for example, in the previous problem you see. In the same problem, they may ask this model. That time no need to find all the steps. From here onwards, you can write down. By Rolle's theorem, there exists a point C between 0, 5 such that f dash C equals 0. This point onwards, you must write down. They ask the question using Rolle's theorem for the given function f of x equal to sin x by e power x. Find the value of x between -2 here, sorry, 0 to pi, 0 and pi, where f of x equal to 0. For example, in the same problem, I don't go for the other problem. For example, same problem, above problem. Just above problem, they may ask like using Rolle's theorem, using Rolle's theorem for the function f of x equal to sin x by e power x. Find the value of x between 0 and 1, where f dash x equal to 2. This is problem 2. But this is a same problem. Here, no need to prove continuous, differentiable, f of a equals f of b. No need to test all the hypothesis conditions. Directly solution. Find f dash x. F dash x equal to e power x whole square, e power x into cos x minus sin x into derivative of denominator. Then make it this value make into 0 or equal to 0. Now f dash x equal to 0. That implies f dash x value is this one equal to 0. E power x into take a common e power x cos x minus sin x by e power x equal to 0. After equating to 0, take a cross multiplication. That implies numerator must be equal to 0. The numerator we have product of two functions. Any one of them is 0. but this never be 0. So second one must be cos x equal. That implies a minus b equal to 0 means a equal to cos x equal to 5. As per trigonometric functions, these two are equal at x equal to 5. At x equal to 5. That's it. Put x equal to pi by 4, f dash x equal to 0. Because f dash x, we start from f dash x equal to 0, we find x value. That means we substituting x equal to pi by 4 in f dash x, we get a 0. If you have any doubt, you verify also. Verification process. This is f dash x value. Substituting cos pi by 4. Cos pi by 4, here sin pi by 4. Cos pi by 4, sin pi by 4 value is 1 by root 2. Here e power pi by 4, 1 by root 2 minus 1 by root 2 into e pi by 4. Numerator is 0. Therefore, 0 by finite value. Denominator never be 0. That means it is a finite value. 0 by any non-zero value becomes 0. Okay. Next, one more problem. Last problem. Last problem. This model problem using Rolle's theorem for the function f of x equal to x minus 2, sorry, x plus 2 whole cube into x minus 3 whole power 4. Find the value of x. Find the value of x between minus 2 and 3. A value is minus 2, B value is 3. Where, where whose derivative at the point is. So no need to verify here using means obviously the given function satisfies hypothesis of the Rolle's theorem. So directly you find derivative and after finding derivative equal to 0, find x value. There are three steps. First find derivative. Find f dash x value. F dash x value equal to, here we have a two functions f of x equal to, here f of x value is x plus 2 whole cube x minus 3 whole power 4. Therefore, f dash x equal to u into v. First function into derivative of second function. Second function derivative is 4 times of x minus 3 whole power 3 plus second function into x minus 3 whole power 4 into derivative of first function 3 times of x plus 2. This is the derivative. Now equal to 0. Next step is take f dash x equal to 0. After taking f dash x equal to 0, simplify the expression, find x value. That is f dash x value is this one. Equal to 0. That is x plus 2 whole cube. 4 is a constant. Keep it before. 4 times of x plus 2 whole cube into x minus 3 whole cube plus 3 is a constant at the second factorization. 3 times of x minus 3 whole power 4 x plus 2 whole square equal to 6. Now take a common factor. Now take a common factor. X plus 2. Here x plus 2 has square. Here x plus 2 has cube. Take x plus 2 is a common. Minimum exponent is 2. Here 3. Among between these two, 2 is the minimum. Take 2. Similarly, x 4 times of 4 times of x What is factor x plus 2 plus 3 times of x minus 3. Here in the product we have three factors. This one, this one, this one. But these two are never zero. In between part. These are 0. First factor is 0 when x equal to minus 2. But we take point between minus 2 and plus 3. Here also 3 is not included. Therefore, these two are not equal to 0 in between the points minus 2 and plus 3. Therefore, this must be only 0. Let me simplify this expression. 4 times of x plus 2 plus 3 times of x minus 3 equal to 0. That implies 4x plus 8 plus 3x minus 9 equal to 0. What about 4x plus 4x minus 3x becomes 7x. 8 minus 9 becomes 1 equal to 0. That implies x equal to 1 by 7. So 1 by 7 is a point lies between thus the point x equal to 1 by 7. It lies between the interval minus 2 to 3 such that f dash of 1 by 7 equal to 0. That's it. Okay. Now I am going to stop this topic. All models are same pattern. In based on the Rolle's theorem, there is a chance ask the questions in these two ways. One is verification, and the verification takes all the hypotheses. We need to verify hypothesis as well as conclusion. The second model is type 2 model is just using the Rolle's theorem, find the XC value. That time you directly find the derivative and equate to 0 and find the corresponding X value. Okay. So of this process, remaining concepts I will send the just like short videos for other all topics.